Okay, actually, this is also a very new concept, a new concept also in 5G. Actually, as you can see here, also the top examples on the right here, this is like assuming there is one transport block being transmitted over the MAC layer, okay? And as you know, the block size might be sometimes very, very big, like for example, not fitting whatever requirement we need. But then the transmit block size as a maximum, it's having a maximum limit. For example, as I remember, it was 8,000 plus for the 8,000 plus, or minimum as 4,000. 8,000, 4,000, different, depend on the coding rate type and so on. So actually, one of the complexity of the channel coding or decoding in general, whenever you have a large packets or the packets is being increasing, the complexity can be limited actually. Can be limited. Like for example, the decoder or the decoder from the receiver side, if you receive a very large packet or large packet as a transport block with the maximum size, this is increasing some kind of complexity. It might fail and so on. This is one of the things. The second, also assume that you have a transport block, as I mentioned, with 8,000 bits, and only one bits, or let's say 50 bits, or let's say 10% of the bits being filled, and the decoder received a complete transport block. So he will need to do the retransmission for the, he will request retransmission for the complete transport block, not only for the bits which is being failed. That's why the 5G introduced this concept which is called code block group. What it do, the MAC layer can do a segmentation to the trans block into small code blocks. You can see this CB called code block. For example, this one is divided into 8 code blocks. Each one of those will have a different size, and those code block now it will attach to each one of those. The green one is the CRC, cycling redundancy check. So the first of all, the receiver can do the error detection based on the transport block, or based, for example, in code block, as you can see, the small one here. But actually, the main problem about the code block only, if the transmitter assume that you divided this one into 8, the receiver, if the transmitter divided the transport block into 8, this means the receiver will need to do send acknowledgement or non-acknowledgement message for each of those. So this will increase the overhead in the PDSCH channel or PDSCH and the uplink, because now instead of sending one ACK or NAC, he will send 8 ACK or NAC. And this is actually, it's a good in terms of that if only one code block is being failed, so this one, only one will be retransmission. So it goes in the retransmission because only the code blocks, small code blocks with error can be retransmitted. But in terms of feedback, still it's not that good, because it will again for the system capacity point of view, especially in the uplink, it will not be that good. That's why they came up with the code block group, which is actually, if you remember the specification, the code block group can be 2, 4, or 6, or 8. What means by 2, 4, 6, or 8? This means that one code block group can consist of 4 code blocks, or 8, or 2. So in this example, I'm assuming that each code block having 2 code block, each code block group having 2 code block, as you can see here. So in this case, for example, the code block group 1 was fine, no errors. Same for 3 and 4. Only code block group 2 having one of them within it, code block 3 was suffering from some errors, so it was being detected by the receiver. So the receiver will only requesting for a transmission only for this one, code block group 2. So in this case, it's sending only for acknowledgement, for example, and non-acknowledgement only for that part. So this only the one with being retransmitted. But there is some dependencies in that part. First of all, it needs specific UE capability, as I will be showing in the next slide. This information you should find in the new capability called, for example, CBG transition indication downlink, supported or not supported, and also flush indication. Also, the here from the network side of GNB side, also to require to support the feature itself. Through that, first of all, it will configure for the user the maximum code block group per transport block. For example, it will tell the user that you can this one, for example, will be combined into full code blocks. The one code block group equal to 4 or 8 or 6 or 2 and so on. And also it can ask the receiver to flush or remove whenever those is being approved. It will ask the transmitter to flush it or take it out of of the buffer and so on. And at the end, this information is transferring through something called some indication called CBG, just to be able to the receiver to identify which one is related to which code block group ID. This will be explained also next. But just in summary, that instead of the transmitter to retransmit the complete transport block, it can just transport a small part out of it if this feature is being enabled, because at the end the receiver will be reporting the non-acknowledgement only for one code block group or two or three. It depends on the errors. So this is will reduce your retransmission in general as a volume point of view. Now let's move forward. See, now next slide will just I will show you how to check this kind of capability from the UE logs. Okay, this one is just showing that how to check the code block group from EU logs. As you can see here, initially in our capability one here, you will go through that physical parameter. As you can see under the EU capability information, you will find under the BDCB or the CMAC, then the physical parameters. Under that part, you need to search for the information which is called CBG trans indication downlink or flush indication. This one was not supporting for the device, while this one was supporting. So this one reporting to the network. I'm supporting the code block group retransmission. So you can now enable the feature if you would like to have it in your network.